Hello, mathematicians. Today we're starting with a dot talk. My question for you is, how many dots do you see? And how do you know how many? And how do you see them? Those of you who are at home, hopefully you saw the 4 here. And then maybe you saw these two halves that equal another one, and these two halves that equal another one. And so you had 1 plus 4 plus 1, which would give you 6. You may have also seen it another way. Sometimes people see the 2 plus these two halves, so they see 2 rows of 3 dots. Again, there's lots of different ways to see it as long as you can explain how you saw it. So today we're going to try a new warm-up. It's called choral counting. And when we were like in kindergarten and preschool, we counted all the time. We practiced counting 1, 2, 3 every day, almost for every day in the year. Well, it's just as important to choral count or count out loud using fractions and decimals, because fractions and decimals work just like whole numbers do in the fact that you can put them together to get other values. So we're going to practice counting, but first, like a mathematician, we need to look and see, what do we notice and what do we wonder about what we see in front of us. So talk to your neighbor partner about what you notice or wonder. Maybe you noticed that each whole was partitioned or broken into fourths. Maybe you also noticed that there wasn't just one whole, that there was 1, 2, 3 wholes. So we're going to practice choral counting. I've also put a number line underneath so you can kind of see. Remember, as we're counting, we're moving further on the number line to a larger value. So we're going to count together. So when you see the new value, you're going to say it with me. So we have 1 1/4, 2 1/4, 3 1/4, 4 1/4. What happens? So now I have 4 1/4 or 4. I also notice that that gives me a whole. Now we're going to continue counting. 5 1/4, 6 1/4, 7 1/4, 8 1/4, another whole. 9 1/4, 10 1/4, 11 1/4, 12 1/4, and we can also write these numbers different ways. We can see that here we have 1 whole, 8 fourths at 8 fourths, now we're going to have 2 whole, and at 12 fourths we're going to have 3 whole. Our learning target for today is I can use mixed numbers, improper fractions, and decimals to represent visual values. So let's check it out. So remember, we talked about how important it always is, and especially with fractions and decimals, that we represent our values visually. So one way we could choose to do it would be like fraction strips, like what we've been using when we've been playing Race to 1. We also can show values on a number line. We can also show fractional values as part of a set, 3 out of 4. And we can also draw a circle or an area model. So these are the 4 different ways or representations you could choose to represent your thinking. Raise your hand if you have a nickname or you have someone in your family who has a nickname. We all have different nicknames, but we're the same person. We use specific nicknames for different reasons. Just like we use different equivalent fractions or decimals in different situations to make problems easier to calculate and to help us more easily visualize the value. So I have different nicknames. Some of my friends would call me Chris. My children might call me Mom. You might call me Teacher or Mrs. Carlson. My sister would call me a sister, and some people might call me a friend. But all those words can still represent me. So just like that, we can have multiple different ways we can represent one value. So in math, if you're being compared with other fractions, then you want to be thought of as a fraction because then it's easier to compare. But maybe when you're adding a fraction to a decimal, you want to change it to a decimal because it's easier to add both of them as decimals. So again, if you can go back and forth between fractions and decimals, it gives you lots of math power to be able to change them into whatever form would make them easiest to work with in the problem you're given. Okay, so we've been talking this week a lot about decimals. Remember, they're a number that uses a decimal point and place value to show magnitude or size. So when we're talking about a decimal, we always think of a decimal point and we think of that place value chart. We also have fractions, though. One type of fraction, we can break down fractions into different types, is a proper fraction. And that's a fraction with a numerator that is smaller than the denominator. Okay, so if I look here, if my numerator is smaller than my denominator, if I look at all these pictures down here, remember I would have a value less than 1 whole. That would all be proper fractions. Okay, sometimes I think about it, the 5 is going to be able to hold the 3 up. It's not full yet, so it's still proper. It can stand up nice and straight. Okay, now an improper fraction is a fraction that has the numerator. So now the top number, or the numerator, is equal to or larger than the denominator. Okay, so in these two examples, they are equal to. Our numerator is equivalent to our denominator, 2 and 2. Or in this one, I have 4 and 4. But again, whenever our numerator and denominator are the same, then we're going to get 1 whole, which is considered an improper fraction. Or if I have a larger numerator than denominator, like 7/4, 5/3, 8/5. Again, when it's improper because the numerator is greater than the denominator, those would be numbers that are 1 or greater than 1 for a value. Next, we have mixed numbers, and that is a fraction with a whole number and a fraction combined together. So if we look here, we have our whole number, and it's written bigger so you can tell it's the whole number. And then we have a regular proper fraction next to it. So when we combine those two things, I can see down here my 1 whole, 2 whole, and then here I have 1/2 shaded. So if I put that together, I would have 2 and a 1/2, and that is our mixed number. So we are going to watch a math antics, just a short part of it, 3.5 minutes, about fractions, and I want you to listen for the examples that he shows of fractions, improper fractions, and mixed numbers. And I'll ask you about them after the video.
Its length is just the number 1. And now let's measure a rectangle that's even longer. Now this one falls somewhere between the whole numbers 1 and 2. To write its length, we're going to need the number plus a little bit more. So that means we're going to need a whole number and a fraction. To figure out what that fraction will be, notice that the space between the 0 and the 1 is the exact same length as the space between the 1 and the 2. That means if we divide the space between 1 and 2 into fractions, they'll be the same as the fractions between 0 and 1, the proper fractions. So this rectangle is 1/2 long, and this rectangle is 1 1/2 long. It's like the proper fraction region is repeated between any two whole numbers. So while our number line counts whole numbers, in between each whole number, it also counts proper fractions. But wait a minute. If there's a whole bunch of proper fractions out here in between the whole numbers, then why have we been calling this the improper fraction region? Well, it's because improper fractions are formed by combining a whole number with a proper fraction, but the whole number part is hidden in the fraction. Starting at 0, you can count up through the proper fractions, but once you pass 1, they're called improper fractions because there's a whole number part hidden in the fraction. As always, a few examples will help this make sense. The improper fraction, 3/2, is right here on the number line. That means that it's just the combination of the whole number 1 and the proper fraction, 1/2. The improper fraction, 4/3, is right here on the number line. That means that it's just the combination of the whole number 1 and the proper fraction, 1/3. The improper fraction, 9/4, would be right here on the number line. That means that it's just the combination of the whole number 2 and the proper fraction 1/4. Alright then, if an improper fraction is really just a combination of a whole number and a proper fraction, then why don't we write it like that? Well, we can. When we write an improper fraction as a combination of a whole number and a proper fraction, we call it a mixed number. A mixed number looks like this. The whole number part comes first, and then the fraction part comes right after it, a little bit smaller. And when you read a number like this, you say 1 and a half. You say the and because it really is like you're adding 1 to 1/2, but you don't have to show the plus sign. Now that we know that a mixed number is another way of writing an improper fraction, we're going to learn how to convert back and forth between those two forms. Let's start by learning the procedure for taking a mixed number and rewriting it as an improper fraction. Now there's a few different ways you can do it, but I'm just going to show you the quickest way. Here's the first improper fraction we're going to rewrite, 3 and a half. Now we know that our answer is going to be an improper fraction, so let's go ahead and write the fraction division.
So share with your partner an example of a proper fraction that you talked about, improper fraction, and mixed numbers. Pause and talk about it, and then we'll move on. So today we're going to practice writing the same visual, using the visual, but writing it in 3 different ways. So we're going to look at our visual model, and then we're going to write it as an improper fraction, a mixed number, and a decimal. So on your whiteboard, I want you to make 3 columns. You can put an I for improper, M for mixed, and D for decimal. And we're going to do one at a time for the first couple, and then we'll let you go on your own. So improper fraction. Remember what they said, if it's improper, that means the numerator is larger than the denominator. It will like fall over. So if I look at my fraction, my first job is always to count how many are in a whole. Well, in this one, I have 3. I need 3 pieces to make up one whole. So if I count 1/3, 2/3, 3/3, 4/3, I've got 5 1/3 pieces. So that would be my improper fraction. I could write it as a mixed number. To do that, I need to show the whole number and the fraction. So go ahead and write down, looking at the picture, how would I change that into a mixed number? Well, first, I know that I have 1 whole here, so that's going to be my 1. And then I have 2 more thirds, so it would be 1 and 2/3. Now we got to go to think about decimals. So I want you to think about a decimal. When we're writing a decimal, we want to think, still going to be the same whole number, so we're still going to have 1. And how am I going to show 2/3? What would each of the parts be if I'm talking about thirds as a decimal? So go back and think about when we were sharing $1, how much would each third be? Remember, it was 0.333 repeating, okay? It would never end, so it gets us as close to 1 as we can. So if I had 2 more of them, I would have 0.66 repeating. Because if I think about it, my mixed number can easily be changed from 1 and 2/3. I can keep the 1, put my decimal and then 2/3 is written as 0.666. Okay, next one, erase your board. Okay, so let's look at this example. So first, I need to figure out what I'm looking at. I have a number line this time that also shows some blocks going across it, because remember, a number line is really how far you go. So if I look at it, I can see I'm going to find 1, and I'm going to say, I need 1, 2, 3, 4 jumps to get to 1. So that means I have 1/4 of a jump each time. So I'm going to list my 1/4s. Okay, so I've got 1 1/4, 2 1/4, 3 1/4, 4 1/4. But I'm not there. That means I'm at 1 at 4/4. But I have to keep going. I've got more. 5/4, 6/4, 7/4. So my improper fraction is going to be 7/4. My mixed number. Now I'm going to change this. How many did I need to equal 1? Well, if I group my 4 1/4 together, that's going to give me 1 whole. Okay, so I have 7 1/4 pieces, which equals 7/4. So now I need to write it as a mixed number. Remember, that's when I have a whole number and a proper fraction put together. So now I'm going to look, how many do I need? How many 1/4 do I need to equal a whole? Well, I've got enough. I need 4/4 to equal one whole. So that's going to be 1. I don't have enough. I would need 8 to equal 2. So I'm going to have one whole, but I'm not done. I still have 1 1/4, 2 1/4, 3 1/4 pieces, or 3/4. Now I can also write this as a decimal. So first I'm going to look, I'm going to say, I know I still have one whole. That doesn't change. My whole numbers stay the same no matter if I'm a fraction or a decimal. But now I need to look at, instead of 1/4, what would I call this? Well, we know that a fourth of a dollar is 25 cents. So we would write, 0, we'd have 25, 50, 75 cents, or 0 and 75 hundredths. Okay, so we could write it as 7/4 as the improper fraction, 1 and 3/4 as a mixed number, or as a decimal, 1 and 75 hundredths. Just like always when we have fractions and decimals, we're going to stop first and look at our picture. What do we notice? Well, I notice that I have a picture that's more than 1, so I'm going to have an improper fraction for it. My first job is to figure out, well, how many total pieces do I have in one whole? Because that's going to give me my denominator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 pieces in every one whole. But I've got 10 here. I've got another 10 tenths here, 11 tenths, 12, 13, 14, 15, 16, 17, 18, 19, 20 tenths. And then one more. So I would have a total of 21 1/10ths. Or if we write that, we'd write it as 21 tenths. As a mixed number, now I need to look at how many whole. Well, I see when I get 10 tenths, I have one whole. I have another 10 tenths here, so now I'm at 20 tenths. So now I'm at 2 whole. I don't have enough to make 3 whole, so I know my whole number is going to be 2. And then I have 1/10 more. Now, if I'm going to write it as a decimal, remember my whole number stays the same. I still have 2 whole, but now I need to think of my how many I have left over here as a decimal. Well, 1/10, I can think of it as a decimal if I divide it into 10 pieces. Oh, I know how to write 1/10, 0 and 1 in the 10th spot, like a dime. Then my answer would be 2 and 1/10. That's how I would write that same picture. So again, 3 different ways to write the exact same value. Again, when you're working with math problems, you get to choose a lot of times which one do you want to see it as or write it as that it's going to make it easier for the problem. Okay, so let's look at this example. Again, your first job is to notice what you see about the number line. I see this time I have 1 group, 2, 3 jumps or 3 partitions between 0 and 1. So that means each one is going to be 1/3. So I have 1 1/3, 2 1/3, 3 1/3, or 3/3, 4 1/3, 5 1/3, 6 1/3, which is going to be the same as 2 wholes we can see up there, 7 1/3, 8 1/3, 9 1/3. Oops, and this was supposed to be a 3. And then one more, which would give me 10 thirds. So my improper fraction would be 10/3, or 10 thirds. That one's hard for me to picture in my head if I didn't have the image there. So I always like to change them into a mixed number because I can picture that better in my head. So if I wanted to think about that, well, my 3/3 gave me 1, my 6/3 gave me 2, 9/3 gives me 3, so I have 3 whole, and then I have one more little third left. So 3 and 1/3 is how I would write that as a mixed number. As a decimal, I could either picture of each of these as a third. Remember we said it was 33.333 repeating. So I could count by that, or I could say, I know it's the same whole number, a 3. I know I'm going to use my decimal point now because that's telling me I'm going to move to my partials. And now I have 1/3 more. How do I write 1/3 as a decimal? Well, we did that over here. We thought about a dollar shared with 3 people. We're each going to get 0.3333 repeating for our answer. So again, these 3 numbers all represent the exact same place. They represent this dot on the number line. But again, you can write it in 3 different ways. Okay, I want you to try this one on your own. write it as an improper fraction, a mixed number, and a decimal. Pause and do that, and then you can check your answer. Well, I noticed my first job I have to figure out how many partitions do I have in a whole. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10, so that means each one is going to be 1 out of 10 or 1/10. I know if I think about, I know what that means as 1/10. We just talked about that. I could write it as a decimal that way too. So if I wanted to write it as an improper fraction, I'd have 1 1/10, 2 1/10, 3 1/10, 4 1/10, 5 1/10, 6 1/10, 7 1/10, 8 1/10, 9 1/10, 10 tenths. Well, I have 10 in this row. I have another 10 tenths in this row. And I have another 10 tenths in this row. So how many total tenths do I have? 10, 20, 30 tenths. I could break them all apart and have 30 1/10 pieces. So that's how I would write it as an improper fraction. As a mixed number. So now it's really hard to picture 30 tenths. But if I group them together in groups of 10, I've got one whole with 10 of them giving me 1, 2, 3. So I have the whole number 3. If I wanted to write 3 as a decimal, I could just remember, put my decimal point, and I could put a 0 after it, because remember, no matter how many zeros I have trailing, I could put 1 0, I could put 2 0, I could put 100 zeros after it. It doesn't change the value when we add zeros to the right of the decimal point. Okay, go ahead and try this one on your own again, and then we'll check it together. What's the improper fraction, the proper fraction, and the decimal? Remember, our first job when we're finding improper is to find that 1 as our benchmark. How many do we need to get to 1? 1 partition, 2, 3. So that means each one is going to be 1 out of 3 jumps, or 1/3. So I'm going to count them for my improper. 1 1/3, 2 1/3, 3 1/3, 4 1/3. Or 4 1/3 I need to make that fraction. As a mixed number, now I need to look at that. It's hard to picture 4/3 in my head. It's easier if I group it 3/3 together, and 3/3 make 1 whole. And then I have this extra 1/3, 1 and 1/3. And then finally my decimal. Well, I know that each of these thirds we talked about is 0.333 repeating. So I've got 1 whole still. I'm going to keep that the same from my mixed number. Now I have 1 extra third. So I'd have my 0.33333 repeating. Okay, so now I want you to look at this one. This one's a little trickier because all of them aren't filled in all the way. So go ahead and write your improper fraction, your mixed number, and your decimal. Okay, my first job is always to figure out my denominator. Well, I have 1, 2, 3, 4 parts in a whole. So my denominator has to be a 4 because remember that tells me how many parts I have in a whole. Now I'm going to color, I have 3 parts colored in this one. So I got 1 1/4, 2 1/4, 3 1/4, 4 1/4, 5 1/4, 6 1/4, 7 1/4, 8 1/4, 9 1/4, or 9/4. Okay? As a mixed number, this one's a little trickier. I could think about bringing this one over here, and then I could maybe think about bringing this one over here to fill it up. So now I would have 1 whole, 2 wholes, and then 1 1/4 remaining. Okay? Now if I wrote it as a decimal, I could think of each one of these as being my 25 hundredths or my 25 cents. So I could count by 25, 25, 50, 75, $1, $1.25, $1.50, $1.75, $2, $2.25. Or I could just look at saying, well, I know it's 2 is my whole number, and 1/4 can be rewritten. It's equivalent to 25 hundredths, so I could have just done it that way as well. Okay, so our learning target for today was I can use mixed numbers, improper fractions, and decimals to represent visual values. I want you to think about where are you now on our continuum? Are you at a 3? You're kind of close, but you still maybe get mixed up on improper fractions or the decimal conversion. Maybe you're feeling like you're at a 4 or a 5. We're going to continue to work on this next week as well. So hopefully we'll continue to move up until everyone's at a 5. If you're in class, your teacher will tell you what you're doing next. If you're an at-home learner, go ahead and look in your Google Classroom for any other assignments that you should complete.